wabarakatuh. Good morning, everyone. Today I would like to explain about the case study on ambient air sampling method with my name as with Haikal Ramadhana Akmal with student ID 2009. So we go into the reference. Here, my reference is about the review on sampling method on health impact of fine like PM 2.5 and ultra fine like PM 0.1 particle. And this is the reference. For the particulate matter or PM is one of the most important parameters in ambient air quality monitoring because it directly affects the human health. The reviewed article discussed various sampling and measurement techniques for PM 2.5 and ultrafine particle, including the instrument commonly used in air quality studies. The paper also evaluated the advantage and limitation of different sampling method and monitoring technology used in ambient air assessment. So, for the ambient particulate air pollution, the particulate air pollution has become one of the most significant environmental challenges worldwide. Fine particles such as PM2.5 and ultrafine particles can penetrate deep into the respiratory system and even enter the bloodstream. Therefore, reliable sampling methods are essential to accurately determine the particulate concentration in ambient air and support effective air quality management and pollution control strategies. So the point here is PM 2.5 diameter like less than 2.5 micrometers, and for the ultra fine particle less than 0 0.1. For the major source include vehicle, industry, and also biomass burning, and associated with the respiratory and cardiovascular disease, and also widely used as a key indicator of air quality. So, for the objective of the reviewer article, the reviewer article aimed to examine the current sampling and measurement technique used for PM 2.5 and ultra fine particle monitoring. It provides a comprehensive discussion of the instrument operating principles, like compare the performance of different monitoring technology and evaluate their applicability in ambient air quality studies. This review also highlights challenges and future opportunities in particulate monitoring. For the ambient air quality parameters, there is some parameters including PM 2.5 concentration with micrograms per cubic meters, ultrafine particle with PM 0.1, particle number concentration or PNC, particle number size distribution or PNSD, particle size distribution, and also particulate mass concentration. The primary parameter measured in the study are PM 2.5 and ultrafine particle, which represent fine and ultrafine fraction of air bonds. In addition to mass concentration, particle number concentration and particle size distribution are also evaluated. This parameter provide important information regarding population exposure and potential health impact of airborne particles. For active sampling method, the article primarily focused on active sampling technique, which use a pump to draw ambient air through the sampling system. Active sampling allows to accurate control of the airflow rate and provide the representative air samplers for quantitative analysis. Due to its reliability and precision, active sampling is the most widely used approach for monitoring PM 2.5 and ultra fine particle concentration in ambient environment. For the active sampling method, there are several active sampling, including use of vacuum pump, control airflow rate, height measurement accuracy, suitable for PM 2.5 and ultra fine particle monitoring, and commonly used in regulatory monitoring. For the passive sampling, it does not require a pump, relies in natural diffusion, and less common for particulate monitoring. For the main categories of PM samplers is based on the airflow capacity. Particulate sampling instrument can classify into high volume sampler, low medium, until low volume sampler, and cascade impactor. Each category offers specific advantage depending on the monitoring objective, particle concentration, sampling duration, and also environmental condition. The high volume sampler, including the high airflow rate, rapid particulate collection, suitable for outdoor monitoring. For the low until the medium volume sampler, including lower airflow rate, suitable for indoor monitoring, lower and also lower operational noise. For the cascade impactor, including separate particle by size and collect the PM 0.1, 0, PM1 and PM2.5 and PM10 fraction. Next, we jump into the Environ Tech APM 550 with the high volume PM2.5 sampler. The Environ Tech APM 550 is one of the most widely used instrument for the ambient PM2.5 sampling. It operates by drawing ambient air through the size-selective inlet system that removes large particles before collecting PM2.5 in a filter medium. The collected particle can be analyzed gravimetrically and chemically to determine the particle concentration and composition, including a high volume sampler with the flow rate 450 to the 850 liter per minute. Use a Teflon and quartz filter based on the USA by design criteria and suitable for long-term ambient monitoring. Next, we jump into the sampling mechanism. The APM 550 operate using inertial impaction and gravimetric measurement principle. The ambient air, the ambient air enter the sampler and pass through the multiple impactor stage that remove large particles. The fine particles smaller than 2.5 micrometers are deposited into the filter, where they are collected for the subsequent mass determination to the filter widening procedure. The sampling process including the ambient air enter the inlet, PM10, impactor remove coarse particle, PM2.5 impactor separate fine particle, PM2.5 particle are collected on the filter, constant airflow is maintained by the pump, and PM concentration is determined gravimetrically. For the operation principle, to the initial inspection and gravimetric analysis. For the ultrafine particle sampling instrument, the cascode impactor are advanced sampling devices designed to separate particles according to their aerodynamic diameter. The instrument consists of the multiple collection stages, allowing particles of different sizes to be captured separately. This enables detailed analysis of the particle size distribution and support study on exposure assessment and Hall effect, including the multi-stage particle separation, collect PM0.1, PM1, PM2.5, and PM10, suitable for the ultra-fine particle research and applicable for indoor and outdoor monitoring, and also provide the detailed size segregate sampler. For the PM measurement technique, after sampling, particle concentration can be determined using a various analytical technique. Gravimetric measurement remains the reference method because it high accuracy and algorithmic acceptance. Other methods such as optical and microbalance technique provide real-time monitoring capabilities and are widely used in research and continuous monitoring applications. So for the gravimetric method, including the filter weighting before and after sampling, and reference method for the PM monitoring. For the optical method, including measurement light scattering by particle and provide the rapid measurement. For the microbalance method, including the measures the mass change continuously and suitable for real-time monitoring. For the electrical method, including measures the electrically charged particle and commonly used for the ultrafine particle. Next, we jump to instrument for the ultrafine particle analysis. Because ultrafine particles are extremely small, specialized instruments are required to quantify their concentration and size distribution. The CPC and SMPS are among of the most commonly used instruments due to their ability to detect particles at a nanometer scale with high sensitivity and precision. So CPC is condensation particle control, including measures the particle number of concentration and height sensitive to ultra fine particle. SMPS, which is the scanning mobility particle sizer, including measure the particle size distribution and high analytical accuracy. Now for the ELPI, or electrical low pressure impactor, including the provide real-time measurement and measures the particle size and concentration simultaneously. For the APS, or aerodynamic particle sizer, including measures the aerodynamic particle diameter and suitable for large particle fraction. For the advantage and disadvantage of the sampling instrument, including the each sampling instrument has unique strength and limitation. Instrument selection depends on monitoring objective, require accuracy, budget availability, maintenance requirement, and environmental condition. Consequently, No single instrument is ideal for the monitoring situation. For the advantage is the high measurement accuracy, representative sampling result, suitable for chemical analysis and exposure and health study. For the disadvantage is the high instrument cost, require regular calibration, complex maintenance procedure, and significant power consumption. For the comparison with the regulatory standard, the sampling method discussed in the article were evaluated against recognize the international and national standard. The result indicate that gravimetric approach to the using APM 550 comply with the principle of the USA Federal Reference Method or FRM. And this is consistent with Indonesia's standard for the PM2.5 monitoring in ambient air. For the reference standard is US EPA 14 CAFR 50 Federal Reference Method or FRM, WHO with the Air Quality Guidelines 2021, and Standard Nasional Indonesia 711915 and 2016. So for the comparison with the regulatory standard, for the active sampling already fulfilled for the standard requirement and IPM 450. For the PM 2.5 selection inlet already fulfilled with the standard requirement and also APM 515. Also same for the gravimetric method that already fulfilled for the standard requirement with the US above 40 CFR Part 15 and APM 550. For the control flow rate already fulfilled with the standard equipment and APM 550. For standard filter media already standard equipment is fulfilled and APM 550 is fulfilled. For the ambient air monitoring is already based on the Federal Reference Method and also WHO air quality guidelines. So already fulfill the standard equipment and APM 550. For the compliance with the APA FRM principle already fulfilled for the standard equipment and APM 550. So, activated sampling is primarily method for the PM 2.5 monitoring, but the gravimetric analysis remain the international reference method. The APM 550 comply with the USFI and SNA principles. The CPC and SMPS are effective for the ultra-fine particle monitoring. The reverse sampling method are suitable for ambient air quality assessment and regulatory application. I think that's all my presentation for the case study for the analysis for the air sampling method. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.